Hey guys, welcome back to the next training. In this training, we are going to see about the standalone server. The same server, the house, which we spoke about, and not the apartment, the house, individual house, which we spoke in the previous example. That's what we are looking at right now. So a computer is divided into three layers. The first one is the hardware layer. The second one is the operating system, and third one is the software layer. Now, we are not going to talk about the software layer, but then we're going to talk about the other two layers because Docker is basically is for hosting softwares, but then we actually don't deal with the softwares at this moment. But as an administrator for middleware or database or tooling, right? So those people will be talking about those individual applications, but then which will be hosted on top of the Docker. So we have three applications we will be looking at later point of time, which when we will talk about the app layer. But in this video or in this group of videos about Docker introduction, we will be looking at only the hardware layer and the operating system layer. So over here is your hardware layer. Now, as you can see over here, you have the hard disk drive, you have the RAM, you have the CPU. Now, it gives you a figure that this is hardware, right? So this hardware is basically is the hardware layer with this following specification, which is about memory about 50 GB, CPU is about 24 cores, storage about 5 terabytes of storage. Now, using this configuration, we are going to host an operating system on top of it. That's called the host operating system. Now, why it's called host operating system? We know it's an operating system, but why you have to specify host is because an operating system which sits directly on top of an hardware. That's called host operating system. Now, well, going down the line, you may see guest operating system. Guest operating system is an operating system which sits on top of a host operating system. That's why we call it a guest operating system. So remember the difference between host and a guest. A host which actually sits on top of a hardware. Okay, so that's basically is your host operating system. Now, host operating system at this moment is utilizing the complete power of the hardware. Okay, which is kind of wasted if you ask me. If you see that the whole reason for you to have this operating system is for this application, the main application, which is about 36 GB. A traditional application, which is a monolithic application, which has no divisions of or classifications of workload, is being configured. It would be configured like this. Either it will be configured in this way or it will be configured in the virtualization way. Okay, so those are the two different methods of configuring a traditional application. But then we're going to go away from the traditional application to the modernization or containerization application, which we'll talk a bit later. But then if you see over here, this is the operating system specification, which is as equal as the hardware, but then it is divided. Now, if you see the memory of 50 GB is divided across multiple sections over here. The main application, we would have given like 36 GB for it to use. And the operating system, desktop, security services like your antivirus and other stuff, which takes about 16 GB of memory. That's all right because that's quite normal for a Windows operating system. And the boot time for this operating system is about 1 to 2 minutes. So that's the boot time, average boot time of any operating system when you have Windows operating system, especially. In terms of storage, you see the main application takes about 1 terabyte, and then rest of the things takes about like hardly 610 GB of memory. I'm sorry, storage. But then we have 5 terabytes, but then we don't have an opportunity to use that for this main application. So it just takes about 1 terabyte. I'm not saying that we should waste the resources, but then I'm just telling you, this is just an example, so don't worry about it. So this is the first item I want to show it to you. This video may take a bit long, but if you have any confusions, do leave a question on the question section. I'll be happy to help you out in clearing your confusions. All right. So moving on to the next architecture, which will look very similar. Okay. So sometimes the image won't fit in, so please bear with me until I figure it out a way to fit it. Because the more bottom we go, it gets bigger. Now, again, there's option one here, which is basically away from, we're just moving a bit away from standalone servers. So we are coming into a concept called virtualization now. Now, if you see over here, we have the same hardware layer out here. So there's no question about it. You already know it. And this is basically your server, desktop, laptop, or whatever it is, hardware layer. On top of that, as an option one, you have the host operating system. Now, it is the same as what we are seeing on the standalone, but then this host operating system and your hardware support something called virtualization. So this is some compatible issues. Like a few days back, if you had an old computer, you wouldn't be able to actually install and configure virtual VMware because it says that you don't have the virtualization enabled on your processor. Now, this is because of that compatibility issue. But then nowadays, all laptops comes with virtualization pre-built on the CPU, so you won't have that problem. So now, if you see that the host operating system is a type 2 hypervisor, there are two types of hypervisors, type 1 and type 2. So this is enabled with type 2 hypervisor in this example. So which means that you can have a virtualization software on top of that, as in like on top of your host operating system. Like for example, for Windows operating system, you have softwares like VMware Workstation, VMware Player, Oracle VirtualBox. In terms of Linux operating system, you have VMware Workstation, VMware Player, sorry, and Oracle VirtualBox. A similar software is available for both operating systems. And then using those softwares, you'll be able to create multiple guest virtual machines, like as you can see over there, VMware 1, VMware 2, VMware 3. So this is just the example name I'm giving. But then these are basically your guest operating system, which runs on top of your virtualization software using type 2 hypervisor. Yeah. So now you understand the concept of virtualization. Now we will talk about the hardware configurations and your memory CPU stuff a bit later down this. It also has this architecture as well. But then this is just to give you an overview. Now let's go to the next one. You can get a tea or coffee while pausing the video, because I'm also relaxing a bit because it is a long it's a long one. Let's go to the next one. Yeah, so here we have option 2 as well. So option 1 remains the same. There's no change in option 1. As you can see over here in the option 1, we have 3 virtual machines like VM1, VM2, and VM3. In terms of option 2 over here, so in this case, it doesn't exist. So that's why we have option 2 over here. In this option 2, it is directly connected to the hardware. So it is called host operating system. And then there is a type 1 hypervisor or bare metal. Now, what this type 1 hypervisor is, and the difference between this and this is that type 2 hypervisor has a proper operating system, all right, like a Windows operating system. Like, for example, my laptop over here. So I do my office work, my personal work, so all those things on my hardware. And on top of that, whenever I want to get some trainings done or want to learn something, I will execute VMware exe file or Oracle VirtualBox exe file, and I will start my virtual machine which runs on that, right? In terms of type 1 hypervisor, it uses the VMware vSphere, ESXi, Hyper-V, Oracle VM Server, Citrix Zen Server. These are some kind of a operating system which is designed only to run virtual machines. So you cannot do normal operations over here. You cannot play games. You cannot do any personal work. You cannot do any office work. You don't do anything on your system. It is designed in a way that it doesn't consume so much memory CPU. All those memory CPUs you have over here will be distributed to your virtual machines, right? So these are the different types of hypervisors you have, and these are different usages of this hypervisor you have in this example I want to show you. In terms of resourcing, if you ask me, it's a bigger diagram. So in terms of resourcing, if you ask me, the similar concept what we have seen in types of option one. So let's first see the option one over here. In option one, the operating system for this the host operating system will consume a huge amount of memory and CPU and storage because you are using it for different or various reasons, right? And then if you see the guest process, you will be actually giving this one of the guest process. Okay, so you can see over here, let me explain this. Let me take a minute and explain this operating system. The hardware remains the same as what we have seen before. It didn't change. Okay, that's 50 GB of memory, 24 CPU, and 5 TB storage. In terms of this particular hypervisor, like type 2 hypervisor, I'm using this as my normal laptop. Okay, so I'm going to have a Windows operating system which takes about 16 GB of memory for the Windows related operations. And then my virtual machine is going to take 36 GB of memory, okay, where the virtual machine will be actually utilizing this 36 GB of memory over here for hosting these three virtual machines. I'll come to that. And then in terms of CPU, it's dynamically assigned, so I cannot assign the CPU to any task until I prioritize some task on my task manager, which I don't want to do it manually. So I will leave the CPU allocations to automatically to the computer. And then in terms of storage, you have 5 terabytes. So you can see over here, VMware has taken 4 terabyte of storage, which I'll give 1 terabyte to each of the systems. Okay, or 1.5 terabytes or whatever to each one of the systems, whichever is available after the utilization from the operating system. And then that similar configuration of when I say virtual or VMware, right? So basically these are dedicated for my virtual machines or VMware servers. So this could be Oracle VirtualBox also. So don't tell me can it be Oracle VirtualBox. It could be anything, any virtualization tool. As you can see, an example for one of the guest virtual machines, you can see that the boot time is much faster than the actual core machine because it is a virtual machine. And you can see the memory, they have taken like 36 GB from here, right? So it is divided by 3, which is like 12 GB each, wherein which the operating system takes about 2 GB. As it's a Linux operating system, it takes about minimum. Security services about 1. And then browser and desktop, if you installed a browser or desktop on your operating system, it's going to take 2 GB more. So total consumption of 5 GB and 6 GB is given to the main service or main application which runs on this particular virtual machine. And then in terms of CPU, we have dedicated 4 core or 8 threads of CPU to each of this virtual machine. And you can see the storage over here is given as 1 terabyte. The operating system needs to have the 10 GB of storage because it has installed the OS, complete OS, right? And then the main application requires 500 GB. Other applications require like other applications and libraries requires like 100 GB. Now, one thing to note is this collection of operating system ISOs. Now, what is collection of operating system ISOs is that say, for example, I'm using CentOS on this particular server. Then this whole operating system, I'm using Windows. And this I'm using Red Hat Enterprise Linux. So here is 10 GB. Not 10 GB, but then around 2 to 4 GB. And then here you have minimum 10 GB for Windows. And then here you have more amount of memory. I think it's 5 GB for Windows, I guess, Windows 10 or 11. And then here you have another 2 to 4 GB. Okay, so here also I kind of have multiple versions of these operating systems. So that's a collection of ISOs, right? So that's about 100 GB of memory I'm giving over here because I may have multiple versions of different operating system which I may have to use on my virtual machine. So this is a collection of it. So I'm just going to give 100 GB. So I have to store it on this operating system. So whenever I want to boot any of that or create a new operating system, I use that particular ISO and boot it up, right? So that's why it's called collection of ISOs. Okay, so I'm doing that. Now each virtual machine has a lot of conceptions over here. This is what we spoke earlier in that example, saying that you your resources are more in your virtualization and standalone server environment. Why? Because you're going to have a host operating system, which is going to take some memory and CPU and storage. And you're going to have the virtual machine where you have installed the complete operating system again, which actually takes again some of your memory, storage, and CPU, right? So this is the problem. You can say it's a problem. But then when you talk about option two, that is the type 1 hypervisor, if you ask me, is it any better? It's slightly better because you're not going to have the operating system for anything else, the host operating system, sorry, for anything else apart from serving the virtual machine. So you're going to have a lesser a memory footprint. You see the operating system processes about 4 GB. All these are estimates. It has no serious versions because every version comes with a different feature which may reduce or increase the memory. All these are assumptions. So remember that. Operating system process comes about with 4 GB of memory. For example, this particular operating system where you have this ESXi operating system installed on it, and then you are giving about 36 GB as virtual, the same one, and then 24 core processor. Now, more amount of processing power will be dedicated to this guys, like even though it is 4 core. And then you have the operating system storage, which basically comes to the same services I've given because not much difference over here. And then VMware is 4 TB, and not much space will be actually lesser when you compare with this one. So I think I copy pasted it. So this must be around 5 GB because it only has the necessary items for it to host or be a hypervisor. So it won't have much memory, sorry, storage space which is required for this particular operating system. It's going to be much lesser. And other services, which again will be much lesser because it is not going to host other services here. It's going to be like 10 GB, I would say, but the ISO collection will be the same because there's no changes in the ISO. In terms of VMware, you will get even much bigger space for 4.5 GB, and you can dedicate those space for your virtual machine. So that is basically is the difference between these two hypervisor versions and virtualization. You may see this very commonly across all the virtualization technology. All right, so we are going to use virtualization for sure in our training, even though we are doing Docker. But then we need something, right? So I cannot use Docker. I can use Docker directly from my Windows machine, keeping my Windows machine as a host. But I want to show you the Linux environment, right? I cannot show you Windows environment and escape because most of the work happens in Linux environment. Almost 90% is on Linux. So it is must for me to show you on Linux. So that's why we're going to use a virtualization software like VMware. And on top of that, we will be having an operating system, like a guest operating system, and within which we will be having the Docker deployed. And then from there, we will be creating containers. And I'll just show you that. So I'll first show you the architecture, what we're going to do. And then basically we will go from there so that you have a clear idea of what we are doing. In terms of I guess this is the last one I want to show you. It's much bigger. Sorry about that. Excuse me for that. Yeah. So now the bigger one, I have readjusted certain things, but then the values remains the same. So we have option 3 now. And option 3 is nothing but containerizing your solution. So here is your hardware specification, your hardware. There is the option 1, there is the option 2. So we don't have to worry about this part of the slide because these are something which we have already discussed about. The one which we need to discuss about or compare it with is the option number 3. So in the option number 3, you have the host operating system, which is Linux. So here it can be Windows as well. There's no issues having the host operating system as Windows. But as I told you, as administrator, you need to know much about Linux more than the Windows part because Windows is much easier. If you learn the hard stuff, the easier comes without any effort. Okay, so that's something I believe in. So as you can see in the host operating system Linux, you have the Docker software. So here is, instead of a virtualization software, we're going to install the Docker software. So in which you'll be actually creating a container, and that's the container 1, container 2, and container 3. Now, how different is this from this virtualization? Let's look at it. In terms of the operating specification, it's going to be almost the same. Let's say that this is a ESXi server. Now you can see that the operating system is about 4 GB memory. Virtualization is 36 GB of memory. And virtual memory is basically what you assign it to Docker. So that's why it is 36 GB. And then you have the same core CPU, the operating system. Again, it's a copy paste. Operating system is going to be 5 GB. Other services is going to be 10 GB. It's not going to be much. And then you're going to have a collection of Docker images is 20 GB. What? This is about 100 GB. Now it's gone down to 20 GB. Why is that? Now, why is Docker images much lower in size? Because Docker images are created, customized images. Why it is customized? Because they want to make sure that only what is required is there, and the rest of the things are deleted. For example, if you are downloading operating system for your VMware server or your VirtualBox server, you'll be downloading the operating system as comes with the operating system guys. Okay, so whatever they believe is the best package size, because they will be having multiple options for you. The minimalistic pack, the normal pack, the extra pack. Likewise, they will have multiple options. A minimalistic pack will also be about 1 GB, much lesser, maybe 800 to 1 GB MB of a file size. It could be like that. But the minimalistic will also have a desktop. It will have other services like FTP, SS. There's a lot of services on Windows, okay, on Linux, right? So I'm not able to think about it. But mostly all these images will be in Linux because it will be actually having only those services which is required. So it's a very tiny image. So if you say an operating system in a Docker is about 100 to 200 MB max. So that's not much, right? An operating system with 100 to 200 MB. But then you can do only certain things in that because it won't have a lot of packages. Okay. An operating system which is designed to be a web server can only be a web server. You get it? It cannot be an application server. It cannot be a database because it won't have those packages which is required for the database or the application server or anything else. So remember that when you're downloading an operating system for Docker or Docker image or what they say, it needs to be for the specific purpose. If it's not for a specific purpose, it's not going to serve you good. Yeah. So now remember that when you are working with Docker images over here, that's why it is 20 GB, and VMware is about 4 TB of our data. And then in terms of one Docker container, what's going to happen inside this one Docker container? The boot time is dramatically less. Why? Because it doesn't have so many services to start up. It only has to start up the services it needs to start up, which is required, right? So that's why it is the boot time or the creation time is just 10 to 20 seconds. When you compare with the boot time of 30 to 60 seconds, this is boot time. Creation time is like long, very long for this virtual machine. But in terms of Docker, it's just 10 to 20 seconds boot and creation time or creation time. And then memory is like security services, nothing. Browser desktops, nothing, because it will not have anything else. So it will have the operating system process. It will be like 0.5 GB, 0.5 GB, which is a 500 MB of a operating system. I would not sure, like even if it would be that much high, it may be lower because there's very less process running. But I'm just saying in the worst case scenario. And the main service will be giving like 6 GB of memory for it to run. So you can see that I'm still saving 6 GB of memory over here by using a Docker. And then I'm going to use maximum CPU as the same as this one, 4 core and 8 threads, because CPU requires for processing the data, but it doesn't need that much of a CPU as well. You can reduce the CPU more, and that basically depends on your application. I don't want to say anything. We have to do proper testing for us to determine what kind of a CPU it requires and how many people want to access it and how many containers you have, how many containers you're willing to spin up when you want to have more users coming in. In terms of storage, not much again, as this is going to be a Docker. A containerized application should be a micro application which needs to be divided into multiple things, and then only you can actually containerize. If it's going to be a huge chunk of data, it's not going to work here, right? So it needs to be application needs to be something which can be containerizable, which can be a smaller piece of work, so that it can do faster processing for that. All right, so now you understand what is a standalone server, what is virtualization, what is containerization, and what are the differences between each of them, and how much resources you can save, and why you can actually save those resources. So I've given you the complete picture of why you need to use Docker. Right? So in the next training, we will see how we can approach this particular session, and then we'll go from there. Thank you so much for your patience in watching this. I'll see you in the next video.